A game board consists of 64 squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q in the top row. A marker is placed at P. A step consists of moving the marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? So we can count this problem by looking at each step one at a time. So there's only one way to get to point P, and that's our starting point. And then we want to go upwards to point Q. So this one has one way of going there, and then this square has one way of going here. So to find each row above, we can think about where it was coming from beforehand. So that means that this square right here, it can either come from this square or it can come from this square. So to find the number on this square, we would add the 2 below it. So that means this would be 2. And then there's one way to go here by adding the 2 below it. 3, 3, 6, 4, 3, 9, 10, 19, 9, 28. So that means that there's 28 ways to go from P to Q, and that's answer choice A. When a positive integer n is fed into a machine, the output is a number calculated according to the rule shown below. For example, starting with an input of n equals 7, the machine will output 3 times 7 plus 1, which equals 22. Then, if the output is repeatedly inserted into the machine 5 more times, the final output is 26. When the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? So we see that these are the rules that the machine follows. So if n is even, then the machine will output n divided by 2, and if n is odd, then the machine will output 3n plus 1. But here we're actually working backwards because they give us that the final output is 1. So we want to work backwards 6 steps all the way up until n. So the inverse of dividing by 2 would be multiplying by 2. And then for this one, we would subtract 1 and then divide by 3. So if we start with 1 as our first value, we want to see which one of these could be the next value. So if we multiply by 2, we'd get 2, and if we subtract 1 and divide by 3, we'd get 0. But obviously 0 cannot work because 0 is even and not odd, so that would not be a valid choice. So 2 is the only next option after 1. And then we repeat this step for 2. So we can multiply by 2 and get 4, or we could subtract 1 and divide by 3, which is not an integer, which means the next number is 4. If you repeat this step, 4 times 2 is 8, and 4 minus 1 is 3, divided by 3 is 1. So with 8, 4 times 2 is 16, and 8 minus 1 divided by 3 is not an integer, and we know that 1 can only go to 2. And then 16 times 2 is 32. 16 minus 1 divided by 3 is 5. And then we know that 2 can only go to 4. And then our last step is 32 times by 2, which is 64, because we cannot subtract 1 and divide by 3 and get an integer. 5 times 2 is 10. And we know that 4 can either go to 8 or 1 from before. So then when we want to add 64 plus 10 plus 8 plus 1, which equals 83, because they're asking for the sum of all such integers n, and 83 is answer choice E. 5 different awards are given to 3 students. Each student will receive at least 1 award. And how many different ways can the awards be distributed? So basically, we want to find how many ways there are to sum 3 different numbers to 5, and none of the numbers can be 0 because each number has to be at least 1. So the first case would be 311 with each number representing a student, and then the other case is 221. So if we start with the first case, one of the students is receiving 3 awards, and each of the other 2 students receives 1 award each. So there's 3 ways to choose which student is going to get the 3 awards, and then there's 5 awards, and we're picking 3 to give to that student. So that would be 5 choose 3, and then the next student has two options because there's two awards left, and the last student is left with whatever award is remaining. So that's 3 times 10, which is 5, choose 3, times 2, which equals 60. So that's for this 311 case. And the next case is 221, where 2 of the students receive 2 awards and 1 of the students receives 1 award. So there's 3 ways to choose which student is going to receive 1 award. And there's 5 ways to pick the award for that student because there's 5 different awards. The next student has 4 choose 2 ways to pick the awards because there's 4 awards left and they're choosing 2. And then the last student is left with the remaining awards. So that's 3 times 5 times 6, which equals 90. And 60 plus 90 is 150, and that's answer choice B. A large square region is paved with n-square gray square tiles, each measuring s inches on a side. A border d inches wide surrounds each tile. The figure below shows the case for n equals 3. When n equals 24, the 576 gray tiles cover 64% of the area of the large square region. What is the ratio d divided by s for this larger value of n? So we want to basically find the ratio of the dark gray area to the whole area of the square. And since we want this in terms of d and s, we should start labeling those things in terms of d and s. So we know that each of these side lengths is s, and we also know that the surrounding border is d. So that means that this is d and this is d. So each square tile has area s squared. And we know that there are n squared of these tiles. So the total area of all of these gray square tiles is n squared times s squared because there's n squared tiles and each of them has area s squared. So we now have our numerator when we're trying to find the ratio of the total gray square tiles to the whole tile. So we want to now find the side length of the entire tile. So with the example n equals 3, we can see that this is s, 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 and then d, 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 d. So that would be 3s plus 4d. But that's because there's 3 of these gray tiles. So in terms of n, that would be ns plus n plus 1d for the side length, and the area would be squared because there's n of these tiles, and then each of these d's is going to be n plus 1. So we know that the ratio of this is 64 over 100. And to simplify this, we can take the square root of both sides. So ns over ns plus n plus 1d, which equals 8 over 10. And we know n is 24, which is what they gave us in the problem. So if we plug that in, 24s over 24s plus 25d, which equals 8 over 10. And then we're going to cross multiply 240s equals 24 into 8 plus 200d. And then, that should be an s. So if we subtract this s over here, that's 24 into 10 minus 24 into 8s, which is 24 into 2, so 48s equals 200d. And we want to find d over s. So we can divide by s on both sides to get 48 equals 200 d over s, which means d over s is equal to 48 over 200. So 48 over 200 is our final answer. But if we look at the answer choices, we have to remember to simplify. So 48 we know is 8 into 6, and 200 is 2 into 25 into 4. So we can cancel out this 8 with this 2 and this 4, and we're left with 6 over 25, which is answer choice A. Rectangles R1 and R2 and squares S1, S2, and S3 shown below combine to form a rectangle that is 3,322 units wide and 2,020 units high. What is the side length of S2 in units? So we first want to start by labeling these side lengths with variables so that we can solve for S2. So if we label S2 as A, we know that it's a square, so each of these are A. And then we're going to label this side as B. So then we know that each of these is A plus B because it's a square and all sides of the square have equal length. A plus B. We know that this is B. And then we're going to need to add one more variable. So we're going to call the side length of R2 here as C. So we know that this is 2A plus B, this is C, this is A plus C, and this is A plus C. And we know that the height of the rectangle is 2020, and that the width of the rectangle is 3,322. So we have both of these lengths in terms of variables. Here we have that A plus B plus C is equal to 2020. And here we have that 3A plus B plus C is equal to 3,322. And we want to find the length of S2, which we labeled here as A. So we can easily see that if we subtract this equation from this one, then we're going to be left with 2A. And all we have to do is divide by 2. So 2A equals 3,322 minus 2020, which is 1,302, and 1,302 divided by 2 is 6,051, and that's answer choice A.